Today we define neighborhood. Neighborhood. So first, what is neighborhood? Let A be any real number, then for each epsilon positive, the interval A minus epsilon, A plus epsilon is neighborhood of A. Now, for each epsilon positive, epsilon should be positive. If epsilon is 0, then it becomes the single point, not the interval. So this open interval for each epsilon positive. That means we have freedom to change epsilon. Epsilon, if we increase the value of epsilon, then this interval can be enlarged, and if we decrease or take very small value of epsilon, then the length of this interval become very small. For example, if I say let A is equal to 1 and epsilon is equal to 1 by 2, then this interval become 1 minus 1 by 2, 1 plus 1 by 2. That means we have 0.5 and this is 1.5. So this interval, or also we can say this is 1 by 2, this is 3 by 2. Now if I change epsilon is equal to 1 by 4, then this interval become 1 minus 1 by 4, 1 plus 1 by 4, or in points you can say this is 0.75 to 1.25. That means if I draw on the real line this interval, this is 0, this is 1. So this interval give the value, this is 1 by 2 and this is 3 by 2. So this interval of this length. And if I take this, then 0.75 will lie here, it is the fourth value, and this value lie somewhere here. So this interval is 0.75 to 1.25. That means as I reduce the value of epsilon from 1 by 2, 1 by 4, the length of the interval or the length of the neighborhood also decreased. So we have been given for each epsilon, so it is depend on us what epsilon we choose. So how this is one, that means in general how can I speak that if this is point A, then after reducing or subtracting epsilon from A, we move from left side and if I add epsilon, then we move from right side. That means this is the total length of the street of the neighbors of A. So as per epsilon changing, this neighborhood also varies, can be enlarged, can be. One thing maybe some students do not understand, this is interval. So one more thing I want to let you know, what is the definition of interval. So this is neighborhood. Interval, what is the definition of interval? Interval, let A, B are real number satisfying A less than B, then AB is the set which contains real number which lies between A and B. Then where A and B can be equal to X, that means AB are included, then AB is called closed interval. Similarly, this is open interval, and the definition, X real number such that the value of X lie exactly between A and B. X cannot be A or B, and this interval, open closed interval, and this you can say that X are the real number such that A less than X less than equal to B. So this is open. Similarly, I can say closed open interval. This is open closed interval. And one more important thing I want to tell you, that what is the difference between set and interval. Every interval is a set, but every set not necessarily interval. For example, if S is a set which contains 1, 2, 3 element, then S is not interval. So this is the contrary example, but every interval is a set. Like this is AB is a set contained in R, and R also itself we call the set of real numbers. So these are the definition of the intervals and neighborhood. Now one more thing, limit point. Now for each epsilon, the interval A, this is A minus epsilon, A plus epsilon, that mean the interval A minus epsilon, A plus epsilon is called neighborhood of A, and because A lies between this, then A we call the limit point. So we define the limit point how? A point or a real number A belong to R is called limit point of a set as subset of R, here write subset S of R if every neighborhood of A contains at least one point of S other than A. For example, other than A. For example, now we come to the example. If S is a set, suppose like this, 1, 1 by 2, 1 by 3, 1 by 4, and so on. This set, element of this set tends to 0. So my question is 0 the limit point of S? So how we check? We first draw a neighborhood around 0, and if every neighborhood of 0 contains some element of S, then we say 0 is the limit point. Now see, if I draw the set S, then this is 0, this is 1, and this is 1 by 2, this is 1 by 3. This set has element like this. If I draw any neighborhood here around 0, then you see this point, because the point of S lies between 0 to 1. So there are many point of S will fall in the neighborhood of 0. Like if I say let epsilon is 1 by 2, then what is the neighborhood of 0? Then neighborhood of 0 if epsilon is 1 by 2, then neighborhood of 0 is minus, that means 0 minus 1 by 2, 0 plus 1 by 2, and after simplification we have 1 by 2 and 1 by 2. That means That means all elements of the set S fall in neighborhood of 0 except 1 and 1 by 2. 1 and 1 by 2, all points lie in this interval. 1 by 2, why 1 by 2 not lie? Because this is the open interval. If it is closed, then 1 by 2 also will be included, but because it is open, so in this case, except these 2 points, all elements of S fall in the neighborhood. Now again, if I take epsilon is equal to 1 by 10, then neighborhood of 0, what is 0 minus 1 by 10, 0 plus 1 by 10, that means after simplification we have minus 1 by 10 and plus 1 by 10. Now accept 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, 1 by 8, 1 by 9, 1 by 10, all points of S fall in neighborhood of 0. So as we change the value of epsilon, we can find many points of S fall in the neighborhood of 0. If you say it is 1 by 100, then how many points of S will fall in the neighborhood? Obviously, except first 100 elements or the points, all the points fall in the neighborhood of S. Now, how many points in S are? Infinite points are there in the set S. So I hope that you have understood this definition. Now my question is, another question is, let S is 1, 1 by 2, 1 by 3, 1 by 4 and so on. Then my question is 1 limit point of S or not? So what is the answer? First, let epsilon is 1 by 2. Then neighborhood of 1 is 1 minus 1 by 2, 1 plus 1 by 2. So if I draw the set S, this is 0, this is 1, this is 1 by 2, this is 1 by 3, this is 1 by 4. Now this neighborhood, if I draw, that is finally 1 by 2 and 3 by 2. So if I draw this neighborhood from this point to this point, this is 1 by 2 and this is 3 by 2. Now because this is open interval, so 1 by 2 also not, so 1 by 2 not the element of 1 by 2, 3 by 2. That means what? What you say? No point of S fall in neighborhood of 1. Similarly, if I have freedom to reduce the value of, if you have doubt that 1 by 2 is very close, so even I can reduce the length of the neighborhood, because if I take epsilon is 1 by 4, then neighborhood become 1 by 4, that is 1 by 4, and this become 0.75 and this become 1.25. That means now this length is from here to here. This is 0.75 and this is 1.25. Now this point do not have any element, not the single element, because epsilon, our definition of neighborhood, for each epsilon, that means every epsilon, even the smallest we can take, more smaller we can do, we can make it, and we do not find any element of S. Similarly, if I change the question, like I say, is 1 by 2 limit point of S or not? 1 by 2. Now say this is our S, this is 0 and this is 1 and this is 1 by 2. So here also I can do same. I can make a very small, because the point 1 by 3 will be somewhere here, 1 by 4 here. So I can draw some interval such that which will not contain any element of S. So actually now in general, how you can understand? If the point become very dense close to some particular point, then it can be the limit point. Otherwise, if the points of the set are scattered far distantly, then it is never limit point. Now, in case of interval, I say our interval is AB. Suppose this. My question is B limit point of AB? So obviously this is A, this is B. if I draw any neighborhood, because the points of this interval from here to this point. So any small neighborhood I draw around B, I always find some point of this interval AB in the neighborhood of B. That means B is limit point. Limit point. If I ask the question, write the set of all limit points of closed interval AB, then all limit points, answer is AB. If I change this question, I make the change AB. Now it is open interval and B is not the part of this interval. That means B is not element of this interval. But still you see B is at a limiting position. That means before B all the point, not B but before B all the point lie in the neighborhood. If I draw a neighborhood, then many points, because points excluding B, all points are of this interval in this neighborhood. That means B is limit point again. Even B is not member of open interval AB, but B is limit point of A. That means if the question write the set of all limit point of open interval AB, answer will remain same, because B is the limit point. So it is not necessary that point must belong to the set. The same case we discussed in the example of as here also 0 is not element of S, but 0 is the limit point. And same here in the open interval, B or A both are not the element of this set. They are out, but still they are limit point. So this is you need to understand. Again, one more example we can say, like, because this interval AB has many points. Suppose here is some point C. Then what about C? Is C is the limit point? That means my question is, C is the limit point? Yes, certainly. Any neighborhood I draw around C, then this set contain many points of this interval, because this interval is continuous. That means all points lying on this segment will the member of this interval, and C, however small epsilon we take, C still contain infinite number of points of the interval. So C is also limit point. So now I think the concept is clear about the limit point.